right, there we go. Are we on? Oh, we're good. All right, welcome. Welcome, everyone, to the first ever GraphGrid Conference. So excited to be welcoming our team here in person and that's joining remotely. Really excited to welcome all of our users and customers around the world. And just to generally welcome the engineers out there, the data scientists, the analysts, and the product folks that are builders and inventors and interested in working with knowledge graphs and AI. Welcome. This event right now is being live streamed from our headquarter office in Worcester, Ohio. And our goal is to make this, not only this is the first event, but our hope is to be able to make this an annual event as we take some time to be able to really, kind of connect with the world, reflect on things we're doing, and hope to, be able to share some of the insights that we have as we're going on our journeys. So just really grateful to be able to connect with everybody today through this. The focus of this event, we're going to spend some time talking about the history and mission of GraphGrid. There's a lot of work that's been done over the last couple years, and it'll be cool to review some of that. We're going to have some time to specifically focus on our Connected Data Platform 1.4 product launch and get some deep dive information on that with some really exciting talks from the engineers. And we're going to take a look at what's next in our CDP 2.0 roadmap and what's coming. A lot of really interesting things as we keep expanding the field of knowledge graphs and integration with AI, and excited to show you some of the things we have coming up and how we plan to advance those. GraphGrid is made predominantly right here in Ohio, and I'm excited for that for a lot of reasons. A little bit about myself. I grew up here in Ohio. From the quote you see on the screen, I think it was Wilbur, right, that said that if you could really choose, or if you could give advice to anyone, it'd be get great parents and grow up in Ohio. And I don't know that you can take that advice, right? That's not how that works. But I'll say I kind of did, and I feel very blessed in that. I have great parents. I had an opportunity to grow up here in Ohio, and just being able to learn, explore, be around a lot of builders. Now I haven't started aviation or anything that interesting as they did, but I still love the spirit of and the birthplace of aviation and building really exciting things that can advance. So I myself am a very passionate engineer, really have found a passion for graph technology over the last 10 years as I've been working in and around it and using it to solve many interesting and exciting data problems, and just seeing how the age of AI has really shaping the data landscape for solving new and exciting problems. So I love building with open source technologies and advancing open source, as well as really developing with cloud-native platforms, and just seeing the combination of how a cloud-first mindset across an organization can create a lot of power for how you can distribute and scale, and seeing those things come together with knowledge graphs and AI. So here in Ohio, GraphGrid was actually founded by me and my brother. To extend the analogy further, yes, I even have a brother, as Wilbur did. Just it's kind of a cool parallel. But we started this in Ohio in 2018 after many years in the trenches, developing knowledge graphs and really just cutting our teeth in how you integrate things with AI and solving some of the platform scalability challenges. So if we had more siblings here in Ohio, they'd probably be part of the company. I'm not going to lie, my parents have said many times, like, wow, why did we stop at 2? We probably should have had a third, seeing the things that you needed in the company to succeed. That's okay. That's okay. We'll just do the 2 of us. So we've been working with graph databases since 2011. Which is now a decade. It's a long time, but it's been enough time to, I think, get a pretty good view of the space and start to have some opinions and build some software that's usable, which has been pretty cool. So I've had the privilege of being able to experience and see the power of connected data firsthand, and see how relationships in data are a really strategic piece that can completely change the game when it comes to AI. We founded the company really on an age of cloud development. We've had a cloud-first mindset as an organization, just being able to appreciate the scale and speed you can move with cloud. And in many ways, we've kind of gone from that cloud-first mindset to then filling out the rest of the software, the enterprise software part of the organization. So it's been interesting to also see the transition for us in taking those mindsets. So to extend the analogy one final time, if I could take what Wilbur said about starting here in Ohio, I would extend it to also say that not only is Ohio a great place to begin life, but it's also a great place to excel towards your greatest goals in life. I think it's absolutely a fantastic place. I've loved the people I've met here, and I've just been so excited to find not only the value of the home experience, but also just being able to make this the place where we can build and grow. So why GraphGrid? Well, that name, as all of our naming, is not honestly that creative. GraphGrid really just comes from literally the fact that you've got a connected grid of services that we call modules that really interoperate together to enhance the qualities of the graph itself, to advance its knowledge and provide a richer engagement, discovery, insight, and augmentation with AI. So it's a whole platform of connected services that are working well together to just further and enhance the value you're getting from your data. And GraphGrid was created to leverage and focus the extensive knowledge and experience we've accumulated over this past decade while we've been creating custom graph-based solutions. So we've really focused and sharpened the platform on knowledge graphs and connected data because we've seen the power of meaningful relationships as a game changer for AI. We've experienced many of the hardships firsthand of building robust knowledge graphs of all sizes. And we've really found that we've been through many iterations of building AIs that have taught us that as the knowledge graph lifecycle advances, as one single relationship changes, that can change a lot for an organization. It can mean finding a missing pattern in a fraud case. It can mean detecting a new bad actor or finding somebody that is a high risk for a sanctions threat. There's a lot of things that one single relationship can mean for many organizations. And one of the things we feel like GraphGrid can really excel at and do well is to provide quality of those relationships and making it effective to integrate with AI to discover those new insights better and faster. So kind of within that is in some ways embodies our mission. We want to be able to natively integrate knowledge graphs and AI together into a cloud-native platform that can have scale and accessibility so that organizations can connect their data with context, discover previously unseen insights, make better, more informed decisions, and gain a competitive advantage and add value with their AI. These are all really essential things to us. We see that there's many organizations out there that have a lot to gain in this next leap as AI becomes relevant. And one of the ways that we see AI becoming very relevant is having very well-defined knowledge graphs in context. That's been one of the keys. You go back to some of these problems time and time again, it's data, it's data. When you start to think about your data in relationships and you have a way to build that knowledge and put it into context, the integration path to AI becomes much better. And we find that having that whole platform together where as you build that knowledge and you can get insights and discover what's there, it helps create a snowball effect where your data gets better, your AI training gets better, and overall you start getting closer to your mission. And that's that's the experience and journey we want to really bring organizations along with us on. So what are some of those organizations we work with? Well, we've been fortunate to work with organizations, many in this early phase. I would say a lot of the early adopters that are looking for knowledge graphs, pioneers that are really interested in AI. A lot of these folks are looking for more intelligent systems. They've seen the challenges that have come with heavy rule-based approach or just trying to fight things with logic or overcome the challenges of just having massive data lakes that you don't know what's in it, right? I think they're people that really want to see a more intelligent system. They want to put some order to the world. And they really see some high-value business objectives that if they break through, they could increase orders of magnitude better than what they're doing today. So a lot of these organizations, we've been fortunate to work all over the world, especially because of our cloud reach. That's one of the primary things. We operate in over 18 regions in Amazon. So it's allowed us to connect over APAC, allowed us to connect in Europe, across all the US and South America. It's given us a broader reach, which is one of the really exciting things about cloud. And then I also think being able to just kind of see the diversity of working with large and small startups, seeing companies at different levels that need to go 0 to 60, build something out, prove it out, lean budgets, how you get something done, show that you can take a small data set, get some value, and also just large enterprises and governments that have huge data sets that may not have been very well taken care of through the years. Large data warehouses that need made sense of, that need wrangled, if you will, and need cleansed. And then also just working with organizations that may have data spread out across the organization. They have a ton of people that have subject matter expertise, but it's siloed, it's not brought together. And helping those organizations work at a plan and a strategy for bringing it together, agreeing on the process, agreeing on standards for their data, and really making it better. So, this has kind of taken us over a lot of different use cases across fraud detection, across anti-money laundering to know your customer. We've worked in personalized telemedicine, working with identity graphs, and even data lineage. So a lot of interesting use cases where when we talk about all of them, they all have to deal with some kind of network or graph or structure. And I think the thing that all of these organizations have in common, and this is one of the things that I've been really just excited about in this space, is there are some of the smartest people out there working in this space. The customers that we have just incredibly smart teams of engineers, data scientists, and analysts, very creative, often themselves have built very impressive systems and architectures for solving very difficult scalability challenges. And it's really cool to be able to work with those teams, because not only do we feel like we can add some value, but we also just get a ton back in return. And a lot of those folks that we find have a very innovative spirit around data strategy. They've come up against the challenges of working with the data that they have in the historical way. They see some of the barriers. And really all of them, I think, kind of have an instinct to know that connected data is valuable. They can kind of see that they need to be able to move to a place where they can really take advantage of connections and take advantage of them quickly, making high-value connections and moving through it. And that's something that I think it almost has an intuition. You can intuitively see how your data can be leveraged to solve your most significant business challenges and provide significant value. And I think that intuition is not a big leap for some. You can see how if you can make those connections across the organization, there's an answer there. And one of the things that I get the most excited about as we go into a lot of organizations is helping them finally make those connections to see that they weren't wrong. What they saw in their mind's eye, the connections across the organization and how they could solve it, that it can come to fruition, and you can make that big leap, you make that big breakthrough. And I think that's one of the cool things about working with a lot of these folks is that in some ways you could call it a sixth sense. They have a belief and a knowledge that there's something really exciting to go there. So I want to take a little bit of time to step back and talk how we got here. We launched CDP 1.4 on September 15th, and that was our first announced launch. But I want to talk about how we got to 1.4 a bit and some of the progression leading up since we founded GraphGrid in 2018. 1.0 was fully cloud-based. As I'd mentioned, GraphGrid is a cloud-first organization. We've developed everything we've done in cloud and provided a full suite of cloud services across 18 regions for our customers in dedicated VPCs with a very hardened security posture and infrastructure. And that was sort of the onset that we approached the company from, cloud first, which I think is still a fantastic posturing. And I'm excited that we have that. But some of our first cases, really showed us that the value of how we could have humans working with machines for data ingest and curation, and some of the ability to really how insights and relationships could change the game. So 1.0 was actually first launched to a customer that we were doing anti-money laundering and know your customer type problems with. And they had over 100 analysts that were curating a knowledge graph and having real-time sanctioned news ingest. And one of the exciting things there was sort of seeing everything, I think, come together. A lot of the value that we saw from those 1.0 customers was the value of time compression for graph changes in discovering new insights. So this was really key. This meant with the knowledge graph set up, you could change one relationship, and suddenly you could connect a person that was part of an organization where that organization was connected to another organization that was doing something illicit. And now you've got a new risk-relevant pathway that is interesting for people to know, interesting for banks to know if they're going to decide who they do business with. And seeing how that one relationship could change and making sure that you were taking care of that one relationship was a very significant matter for that organization. And we find that still today, is that there's a lot of decisions, whether it's finding fraud, finding what fraud you go after and investigate, or it's providing great recommendations. The relationships really matter. And being able to provide them accurately and compress the time it takes to get that data in and have the system be aware of it, and be able to act on that one change is a significant thing. And we were also able to kind of demonstrate a lot of data accuracy in that process. So in that deployment, we ended up having 2 different environments, an internal research environment and a production environment that data was published out to. So it allowed a lot of very targeted operations to be done where you could curate, you could build up the data you wanted, and then you could publish it out. And then, of course, being able to provide fresh insights through AI. So as soon as that relationship change happens, what was the time to be able to have new, fresh insights? What was the time to train? And realizing that for a lot of use cases, being able to decrease that time and really compress that down so that you can get fresh insights, fresh patterns, is very essential for a lot of organizations. And so a lot of that shaped, I think, what we saw CDP could be, a living environment that's constantly evolving and changing as knowledge flows in, as relationships change, feeding the broader ecosystem so that search is constantly updated, so that you're able to continuously train on the data that you have in that graph, so that you continuously discover new patterns, new insights. There's a lot of value in that for that living ecosystem. And so now if we fast forward 4 years to where we're at today, that was 1.0, and I say maybe 4 years or 4 releases, not quite 4 years, but 4 releases later. One of the things that we feel like we see happening really well is designing CDP for engineers, data scientists, and analysts to all work together. We see an ecosystem where data engineering is essential to be able to identify, extract the right information, transform it, and bring it in to build valuable knowledge in the way that the knowledge model is defined to. Data scientists being able to have clean data that they can leverage, and analysts being able to work on control of the knowledge model, what's going in, working on some of those hard things like naming, which everybody struggles with, to bring the knowledge graph completely together. And I think from this we kind of see that for a lot of organizations, this knowledge graph is one of their most valuable business assets. As you get this data really well put together and you see the value of the connections in the graph, that data becomes extremely valuable for what you can build on it. It's not just solving one problem, it's not just solving 2. It's often leverageable to solve many different problems and see data and insights from many different angles. And so a lot of what we feel like we want to push toward is effectively integrating AI to empower these teams to solve some of their hardest problems. And I think that there's a couple ways that we're looking at doing that as an organization. And I'll talk about just those 2 ways, and they're essentially the 2 pillars of CDP. The first one is bettering knowledge graph creation. Overall, we want to focus CDP constantly on how we better the process to create knowledge. And so that means a combination of being able to have great machine-driven ingest as well as human curation, with really strong controls over the knowledge model so that you can manage the knowledge domain. You have clarity of what is in your graph. You know the people, places, the things, and you have an ability to work with those things throughout the whole platform, and it can be responsive to it. And I think with that, being able to power dynamic search and discovery so that everybody in your organization can know what is in your knowledge graph. Effectively democratizing the data that you have in your knowledge graph across your organization is very valuable for many use cases. So that you can see what's in there and you can have really great clarity on how you can continue to advance it across your team. So bettering the knowledge graph is always going to be a core part of CDP, and we want to continue to enhance that with every release so that we can make it easier and more efficient for larger teams and operations to keep building up knowledge. The second thing is to be able to really gain an AI advantage. Most organizations see that the best competitive advantage that they can get, or the competitive edge they can get, is through a path of integrating with AI effectively. And to do that, we really see that there is a huge value that can be achieved through well-defined knowledge graphs. Having just data, or data that's not in context or not connected, isn't really providing as clear of a path to unlock value in AI. It's really about having well-defined knowledge graphs with data in context, with a team that has a good understanding of what's in there, but that leads to being able to have really effective AI. It's the thing that can power and fuel data scientists to be able to be creative and understand how they can build the right models and integrate with it. So there's a couple ways that we plan to really integrate AI effectively in CDP. One is that we want to have really tight integration for some AI models and some AI capabilities. Natural language processing is one, and that's one we're going to spend a little bit of time on talking today about how we're advancing and integrating natural language processing within CDP 1.4. But there's a lot of opportunity for building a knowledge graph based on extracting unstructured data and building it directly into the graph. And that's one of the exciting things that we see about some of those AI models that we can more tightly integrate, is that they can provide more clear value immediately with already existing trained models, or the ability to train a very light layer on top of already very powerful models. But have them very tightly integrated so that they provide some high-value functionality right away. The second way is that we want to always support the ability to have very low-level AI model development. A lot of what we've seen through the model training pipelines where we've been successful is that it often takes a combination of a lot of data transformation, extracting the right data from the graph, transforming it, and being able to feed it in through model pipelines that often involve a composition of other models. And so being able to have more low-level integration with the different AI models out there, and have an ecosystem where you can introduce those in a scalable, integratable way that's still responsive to the changes in the knowledge graph, is part of the ecosystem we want to build in. And that kind of gets into the third point, which is that we want to be able to provide for continuous AI training, whether it's the models that we're providing and advancing that you're building on top of, or it's the lower level models that you're developing with your code and you're providing to the platform. We're working towards facilitating the continuous AI training and model storage, deployment and validation and promotion of those models. And that's something that we feel is a core pattern, a core capability that CDP will provide. And what we think this does is it really culminates in letting organizations take control of their data and have reproducible AI that they know. It's not coming externally. It's data that's within your system. It's data that you've built up, and now you're able to continuously train on this and advance it. So, overall, I think with CDP 1.4 and beyond, you get to benefit from a lot of our experience. Years of hardening the platform. We've got over a decade of experience now to date going into graphs in general, and have been thinking about and working on CDP for the better half of the last 5 years. And we really culminated CDP 1.4 into a packaged product. You don't have to build it from scratch. You don't have to think about the platform architecture. It's an open data architecture. Data is always yours. And you can really work with CDP in a hassle-free way with our cloud if you don't want to work through a deployment path. But our goal with making CDP 1.4 available for download is to really start to provide a way of condensing that package of good things down as much as we can. There's a lot of good things in there, like 4 databases and integration tiers and just a lot of stuff. So there's a reason the package is big. But I think over time we want to try to work at condensing that down and really focus on the things that package needs to do effectively for the right use cases. And so that's some of the reason for the 2 additions that we have. As we go along as an organization, community and connection to our developers and the end users are very important to us. We've spent a lot of time in this last release of 1.4 working on documentation and really trying to sharpen the product and create and focus on developer experience, which we'll talk about in a bit. But community is really important to us, and There's a couple ways that we're involving in community right now. One is through open source with the Graph Foundation in developing ONGDB, which is the Open Native Graph database that CDP is built around. That's a scalable native graph database that's 100% open source, open data formats, so you always own your data within our platform. And it's currently been supported by GraphGrid as well as other community organizations in development and production. So our goal really on the open source side is to keep the graph database open for everyone so that all the possibility of open graph scale is available constantly to the masses, and really working through the committed community to keep advancing and evolving that technology for everyone. So as we look at kind of the Graph Foundation, we're really proud to sponsor, work alongside them, and of course lead a lot of the efforts there. I myself find that I'm kind of hooked into a lot of things these days, so it's really cool to be a part of also of leading that and seeing the side of being able to advance graph technology for public good, collaborate with the broader graph community that really wants to see the open core graph database continue to advance faster. And just really power that native graph mission forward for everyone. So really excited to have the Graph Foundation kind of be a part of this story, and have had a lot of the work done over the last 3 years to cement that and make sure we have a clear path there to be great. And I think with that, one of the things that really spoke to us is that in launching CDP 1.4, it wasn't just enough to make this a package. We really wanted to make this accessible to everyone. And so that's why with CDP 1.4, we're introducing a freemium model that we think is going to be awesome for so many users. Really after 3 years of empowering customers to build better knowledge graphs and effectively integrate with AI, we're taking a really big step forward with 1.4 here. And that's why we're excited to announce that GraphGrid Freemium Model for CDP. And what that model looks like is that you can use CDP for free in production. As of today, and as of our September 15 launch, but definitely as of today, get 1.4.2. As of today, all CDP 1.4 editions can be used completely free of charge in development and in production. And I'll talk a little bit about some of the constraints around that, because there are a few, but we think that it's going to allow organizations to, the goal is to have organizations be able to run completely free forever. And this is going to power a lot of really exciting applications and products out there. So for those organizations that end up exceeding the bounds, which I'll talk about in a bit, our cloud-first approach for pricing has very predictive scalability to make sure that if you're going beyond the kind of free tier levels, that this will scale with your organization really well. So the freemium license covers all editions. One of the things we wanted to do with this is be able to really make the full breadth of the product available. There's a lot of discussions about trying to carve out different editions. Some might be free more than others. But one of the things we feel like we really want to do is just provide all the benefits of CDP to everybody for free. And the main constraint that we're working right now is that you can do this for up to 8 CPU cores, 32 gigs of memory, and 1 GPU. Now that's a lot. That's a workhorse of a machine. You can do quite a bit with that amount of processing. And for a lot of the customers and a lot of the applications, especially startups, nonprofits, those without a huge tech budget, those without a high amount of data, this provides a very affordable way, free, to be able to get building your knowledge graph and solve a problem, right? And what this means is that you don't have to come to us, right, for a license to be able to get going. You can get going with freemium today, and you can run in production forever. And I think that's really going to, our hope through this is that it's going to power the next generation of a lot of intelligent applications and product experiences. This will open the door for small organizations, those that don't have a need for, large knowledge graphs, large amounts of data, that put heavy constraints on resources. This will allow you to get going in a very efficient manner. And this already allows you to have quite a bit of scale. 8 cores and 32 gigs gives a pretty good amount of scale. And especially if you're tapping into GPU support for the AI training and execution, 1 GPU can actually get you pretty far. So for a lot of applications and a lot of initial launches, this is going to be a fantastic opportunity for folks to build and run entirely for free. And we think that that's going to really allow organizations to gain access to AI better and lower the barriers for many. So it will. I think is very, very exciting news for folks. So I think with that, I'll just summarize by saying, this is the kickoff. This is really kicking off a new chapter for GraphGrid with the launch of our 1.4, making this available, continuing to expand access in our cloud where we have been. We've come really a long way in our knowledge and application of graph technology, our engineering experience in developing a scalable platform, and really the ability to produce a product that furthers our customers' missions. So we've been very excited to partner with our customers in this journey and to get feedback and just really welcome that feedback. We certainly haven't solved everything. There's a lot more to do. I think 1.4 is a baseline for us. It's an opportunity to bring together a lot of the things that we've developed over the last 3 years cohesively, and we're still working on it. And we're still working on really advancing it and making it better, and that's kind of our focus and our promise to continue doing so. But with CDP 1.4, we really feel like we've created a powerful platform that's capable of helping you solve really big business problems with your connected data. It's a packaged download that can improve your accessibility and deployment, and it has a freemium license to run CDP in production for free. And there's also a very clear path to economic scalability with our cloud-first approach. So I think all in, that really makes for a pretty exciting story. So we can't wait to see what everybody's going to do with CDP. I think there's a lot of awesome potential there. And with that, I will close by saying welcome to the conference and welcome to everybody, and excited that we're all here. And I'm glad we could have some time to go through CDP, and thank you for joining this first part of the session. I'm going to hand off now up next to Mike Ulring, who's our Director of Product, and he's going to take you through some of the more specifics about 1.4 and what it's all about.
Well, good morning. Mike Ulring, Director of Product for GraphGrid. As Brad mentioned, excited to share with you this morning, this afternoon, this evening, wherever you're watching or listen to a replay from. We're going to talk about CDP 1.4 in more detail. As Director of Product, it's my privilege to have that opportunity to walk you through some of the more specifics. It's been an exciting kind of ride to get us to this point, as Brad was just alluding to and covering. And certainly the team assembled here in the room with me has put in a lot of work over years, but especially in the last kind of 6 to 8 month stretch to really get to this point. I'll navigate my clicker here. There we go. So some of this is redundant, but things that are important or valuable are worth saying twice, but some of this was covered by Brad. We had some goals for 1.4, specifically to make a packaged available for download. That's a key piece to having a product get out there and get use and start generating the feedback that we want to generate. So that was crucial for us. Another key piece is something that Brad touched on, is we want to reduce barriers and help developers be successful. Trying this out, figuring out what they can do with it, and putting it, in motion. The freemium aspect, again, something Brad was just closing with, is a kind of, for us, a differentiator or something that we feel really makes the accessibility right there and obvious, that you can just download it today and try it and start, working with Graph. Beyond that, for us, and this is crucial for a product person, we have feedback. We need more feedback. We need more interactions with customers, with people really using CDP. So the more it gets out there, the more use it gets, the more people generate that, or we generate that feedback and collect that feedback, the more we can improve it and understand how to grow and move forward and make some of those hard product decisions. So I'm certainly excited to start getting my eyes and ears open for what you guys are doing and how you're using it. Beyond that, the last bullet here is it's important for us to launch a product and start getting a little more formal about certain practices and processes internally to better support you, to better grow the platform. So that's been a key piece for us to dig into or focus on as well. As far as kind of post-launch now, we launched 5 weeks ago today. There's some objectives or things we want to track and achieve. We've got a product out there, downloadable on the website for the first time. Tracking downloads, tracking who's using it or who's trying it out is a big piece of that, just so we can kind of keep our finger on the pulse of what's happening there. We have certain customers that are in the field that are in different former versions or previous incarnations of what GraphGrid is in 1.4, so we want to try to migrate all of them as much as possible to be in a common 1.4 stance or instance. We have a current customer that's going through an evaluation of that migration process, so kind of getting to prove out that there's a path there and work through some of the struggles, as you might expect. And then we're going to be increasingly out in the internet, supporting customers, answering questions, again, generating and collecting feedback. Zendesk will be kind of the focus for customer success portal. We have that started, but we're going to build that out and continue to enhance what's available there. And then certainly, community spaces like Reddit, Discord. We'll have additional content on YouTube shortly. Those are all key pieces for us to continue to support and grow that community component of what the product is all about and how we can better serve you, better understand how to better serve you, et cetera. And then, going forward, CDP 1.4 is it for us. That's the preferred platform. Any current customers, any current relationships, that's what we're promoting. That's what we're trying to migrate the business to and future versions as we continue to build out the platform. Just a little more on downloadable packages. CDP 1.4 is not shockingly, but it is really easy to it's a big file, but when you have it, it installs and it does what you'd expect it to do. We've put a lot of effort into making it a pretty straightforward installation process. This is the foundational thing. You've got to get certain things right out of the gate, and being able to download it, get it up and running in a matter of a few minutes, that's kind of expected, and we feel pretty good about our success there. And then along with the package comes the documentation, built-in website that supports all the API documentation. We have tutorials available to walk you through some of the high-level features to get you started. And that's part of that community aspect as well, is continuing to support the users and the developers that are trying this out and looking to solve problems with CDP. So that's a piece that we're very focused on too. More on the docs and tutorials. And I'm looking right at her in front of me. You'll get to know Vanna because she's going to be our YouTube presence primarily for some video content that goes through the tutorials we put together. This is a key piece, and it's a differentiator in some respects because I think we're doing such a good job at it, and I think it's a focus in a way that some other software companies might document their platform or their program, their application, tell you the basics, but they don't really help you. We're really trying to take that, come alongside you and help you approach and give you the tools you need to be successful from a documentation, from an examples, from a tutorials, extending further into templates and SDKs, et cetera. So that's a big piece of this for us. And that the hope is that then if you can see examples that are working and doing something interesting and solving problems, you can extend those or leverage those to apply them to your own problems. So what's actually in CDP? This is a little graphic that shows the two editions, Enterprise and Ecommerce. Mostly the same, pretty easy to see the checklist there. The difference is obvious that payment is the module that's in the e-commerce edition, as you might expect, to have some e-commerce capabilities. And NLP is in the enterprise edition. The e-commerce edition ends up being a little more lightweight because it doesn't include NLP for those that want to go that route. But certainly the enterprise edition with NLP is a little bigger to download, but offers that suite of NLP features. So we're going to dig into each of those from this just a little bit further. And then a couple of these we'll talk about more in depth with some engineering folks that are going to help me out next. Manager is kind of our, as you expect, it manages your data model. It manages a lot of what's happening in your knowledge graph. This is something that we've already iterated on it to arrive where we are with Manager, but it's going to get a lot more love and attention going forward, mostly in the UI to better enable you building out your knowledge graphs. It's, as it says, adapt and scale your graph to meet new and changing business needs. That's, for me, that's a key piece of what graph and building out your knowledge graphs. Things change, and you need to be able to respond and have your data model, represent that and effectively handle that. And so our Manager module, if you will, is very good at assisting you or enabling you to build out that knowledge graph and the model that's required to do that. Another key piece of what Manager is, it's where you create and define ShowMes. We'll get into ShowMes here a little more detail in the next slide. ShowMes are our kind of dynamic, customized dynamic API. It's kind of a canned report type approach, or a way to reproduce a query in a traditional sense, to reveal some sort of insight or some sort of result, and then repeat that as the data changes. You're going to see different results. So it's not a terribly, I don't know, it's cool, but it's pretty obvious at the same time. The Show Me title is self-explanatory. You show me this, and then your data may change in a minute or in an hour, and you can run the same Show Me and get a different result because your data is changing. So it shows that new data in real time. And then the cool piece that I'm excited to see in action more as time goes on is chaining them together, having Show Me output be used as input to an additional Show Me. That's a real powerful thing to recognize how to connect things and then dynamically produce new results with successive Show Me calls, et cetera. Search, on the one hand, search is pretty much universally understood these days as the best way to go and find something. You retrieve data, or you retrieve some sort of answer to your question or results. How we've done search is a lot more, I guess, complicated behind the scenes or under the hood, and Alex is going to go into that here in a little bit, which will be exciting. I've learned a lot from Alex just talking through some of his presentation this morning. But it's, again, the desire to find answers or find insights, reveal something from your data that you wouldn't otherwise be able to get without powerful search capabilities. Context awareness, when you're talking about searching in a graph setting, is certainly a powerful piece of this. And then continuous indexing, which Alex will spend time on, again, is a piece that really kind of differentiates or helps raise what our search is doing in GraphGrid and CDP. I won't steal more of his thunder. He's got some cool stuff to show us in a little bit on search. Similarly, we'll have another kind of deep dive presentation on NLP from Harry shortly. Lots I could say about NLP, but I wouldn't do it justice compared to what Harry will present. At the surface, what this slide obviously covers is you're talking about text-based data, unstructured data that's coming from all kinds of sources, news media, social media, whatever you have that's a text-based source is something that can be fed into NLP and produce, graph-based data that can be understood and, used to discover all kinds of things from that text-based data. The list of bullets here are just some of the highlights of what we have in our NLP module. The best way to experience it really is to download it and try it and start playing with it to really see what it does. And we'll see a little bit more detail when Harry takes us through what he has on NLP. The Curator portion of CDP is, I guess, the most universally understood front-end component, where we have our dashboard, where we have our data viz capabilities. This is something that I think we have a good solid foundation in the current platform for CDP 1.4. We're going to continue to focus and build out what the front end offers, and as far as the API is there's a lot to our API. What's represented in the front end is a piece of that. We're trying to extend or expand the coverage of our API through the front end. So that'll be in future releases as we kind of prioritize the roadmap there. But for where we are now, it is the Curator is the key component to interacting with your graph data through a front end, user interface, et cetera. And then there's different views or different ways to see your data and start getting some data analysis capabilities through that, visualization tools, et cetera. Fuse module, appropriately named. It does a lot to kind of combine things or bring things together. It is our event-driven capability. There's more to it than that, but it's a subset or a collection of our microservices in our API. And the piece that I'm still trying to get my head wrapped around and understand is just everything that it can do, and the potential for what Fuse offers as we go forward. The triggering, the communication between different modules and components is powerful, understatement. And the likelihood that this is going to be even more important for the platform in future releases is pretty obvious. It uses kind of standard policy and messaging patterns. And part of what Fuse offers, kind of beyond just the event-driven, is data replication, batch writing capabilities, as you see here on the slide. And then, we see that this is going to be part of the extensible API for users to customize, what they need. And Fuse is going to be something that they'll leverage and interface with as they're doing their own custom kind of development to come alongside what CDP is offering. Payment, which is only in the e-commerce edition, is kind of our e-commerce capabilities module. Pretty straightforward to be able to create and manage customer payment profiles, do invoicing. There's ShowMe stuff that is connected with payment, as we touched on ShowMe's earlier, which is a way to better understand and trigger what needs to happen in the e-commerce domain. There we have connected with PayPal and Authorize.net for payment processing. We have one-time order capability, as well as kind of using a recurring or a customer payment profile to do that. But the overall kind of goal is to create a smart shopping experience, at least provide the building blocks or the capabilities that you would use to create that type of smart shopping experience that most of us are so accustomed to having when we interact with e-commerce. Lastly, certainly not least as far as the modules we're covering in this overview, is security and config. Security is important to us, and we recognize that as we're dealing with your data and data sensitivity and data security, that we need to handle that well. So it is something we take seriously and are focused on. We did go through a penetration test as part of this release cycle for 1.4, and are addressing certain things that nothing critical came out of that report, but we're addressing certain things in patch releases and certainly the next major release to make sure we're continuing to maintain the confidence in the platform that we feel is justly deserved at this point. From a security standpoint, our security module offers what you'd expect around authentication, authorization, user management, and client access. And then the other kind of just table stakes expectation is that we have config, and the config we are currently including with CDP 1.4 is something that is the culmination or kind of the result of the iterative development cycles that GraphGrid's been in for years. So it maybe needs a little attention, and we'll get to that when we talk about the next release, but it certainly has the ability to configure and control the relevant settings or the things that toggles and things you need to be able to manage from a config as you would kind of come to expect. So, I guess, launching 1.4, Brad touched on it. This is a pivotal thing for GraphGrid. This is a big deal to the people in the room here that we've gotten to this point, that we actually shipped this initial downloadable package version. I give them all the credit for the work they've put in over the years for some in the room, and that's a big deal. But this is a pivotal point for us to really say we're going to put this out there. We want to get traction in the marketplace, have people start using it, telling us what's great about it, what's not so great about it, and get that feedback loop going. That's, again, a plug from me, super relevant and important for me to be able to start getting some of that data back in. But we as a team take a lot of pride in how we've gotten to this point and what's out there in CDP 1.4. I'm excited to move forward from this, as we kind of drew the line and said this is us saying 1.4 is ready to go, and we want you all to try it. We're going to continue to grow internally as a team as we figure out what we need to do and how to do things better. We want to grow with partners, with users, with engineers, with data scientists, with all of you out there that hopefully are interested and curious to see what it's all about. Yeah. I guess the thing I'll close with, and is we've got Alex coming up next to talk about search in more detail and our continuous indexing. I work with a group of great engineers, and I've really been privileged to kind of help lead them in some ways, but certainly learn from them and come alongside them to move us to a point that we're positioned to be successful with this product. And two great examples of that are the two gentlemen you're going to hear from next, in Alex and Harry. And so I guess I won't steal more of their time or their thunder, and I'll hand off to Alex here. He's got a couple setup things to do, but he'll be with us in just a minute.
Hi everyone, my name is Alex Hudis. I'm the Senior AI Engineer here at Atomrain, and today I'm here to talk about the GraphGrid search module. So, some background. I think we can all say that we've experienced searching for something, whether that be a friend on Facebook or just a programming question on Stack Overflow. We've all experienced that. And so we want to do something kind of similar here with our graph data. We want to be able to search for information on our graph. And ONGDB itself has some basic textual search, but it's often not enough. And so we're going to use something called Elasticsearch, which is its own separate database of text storage and text retrieval. And so high-level concept is we want to take data in our graph that we want to be able to search and put that into Elasticsearch, because then we'll be able to search it. And our search module actually wraps Elasticsearch functionality. So pretty much anything you want to be able to do in Elasticsearch, so certain types of special queries, you can do those through our search module. So some key terms, indexing. I'm going to be saying indexing a lot. Indexing is the process of actually putting that data into Elasticsearch. And once we do that, we can search for it. Searching is the process of getting that data back through a query. And then two kind of extra key terms that I want to mention here is just an Elasticsearch index, which is basically a place to store your documents, and the documents themselves, which are these searchable units that contain properties that you'd want to search for. So an overview of the search module that we're going to talk about. First is deciding what you want to be able to search. This is a really important question because it informs us of how to do indexing and how to write our queries. Indexing, we're going to go over basically use of it, so generating and customizing it, actually running the indexing and doing operational things, and then setting up something called continuous indexing, which is an event-based indexing. So when you update your graph, Elasticsearch updates too, and search results are immediately available. And then lastly, we're going to look at some search queries, the so-called simple query and the advanced query, along with, as Mike had previously mentioned, ShowMe's also apply for search. So while we're going through this presentation, we're going to be switching back and forth between the slides and our demo environment, basically. And so we're going to be using the movies graph, which is available on all ONGDB instances. And we're also going to be using the tool Postman to hit endpoints. Usually we'd have a front end calling these endpoints explicitly, but because I'm showing them off, we're just going to be hitting a button to do it. So the first thing is design. We want to be able to design what we can search for. I find it best to design with specific features in mind. So what do we want to be able to search? Do we want to be able to search people by their name or when they were born, or potentially what movies they've acted in? So some questions you might ask yourself is, what's the intended use? Who's going to be using it? Where is this response going? And I mentioned this on the last slide, but usually this stuff would all be kind of filtered through a front end, because we're going to be working with JSON structures that aren't user friendly. So for our examples, for the movies database, we have two features that we want to implement. First, for person and movie nodes, we want to be able to just search by their node properties. That's pretty straightforward, I think. And second, anytime that we search for a movie, we want to get all the associated people back with it. So if we search The Matrix, for example, I should be getting back not only The Matrix, but The Matrix Reloaded, The Matrix Revolution, and Keanu Reeves, and the Wachowski sisters, etc. All right, indexing. So just I'm gonna take a drink of water. The broad purpose is to make graph in the data searchable. And indexing does that by moving information from our graph to Elasticsearch. There's kind of two parts to this. The first is the index policy, and that tells us how to move that data and what data to move. And then there's the operational aspects, which is actually moving the data itself. So the index policy tells us what and how to move it. And that's the most, that we're going to get into that later. That how is really powerful because we can write custom GQL queries to basically get exactly what we need. The core sections of the index policy basically define how to map like a node, like a person, and put that into Elasticsearch. There's some additional features like custom index settings, granular view requirements, so like role-based visibility of data. And so like index policy follows a predefined structure, so they all kind of look the same. If you had two right next to each other, they might look almost identical, but their contents are going to be specific to the graph that you're working with. And at that point, I will just quickly show what an index policy might look like. So this is actually a very simple index policy. I know it looks kind of frightening at first, but what it's doing is it's setting up indexes for two types of nodes, a movie node and a person node. And so we have our movie at the high level right here. Oops. And in the movie, when we index it, we want to include things like its tagline or its title. And for person, down here, we want to be able to include things like when they were born or their name. And so, as you saw, you couldn't write that index policy by hand. It's just too long. It follows like a really specific structure. And so to get around that, what we do is we generate like a base index policy, and that provides out-of-the-box functionality for searching on those properties that I just showed. So like if a person node has name and when they were born, when we generate a policy, it'll include those in it automatically. We can generate a policy specifically for node types, and so like if we have a bunch of different types of nodes on the graph, I can just be like, I only want it for these couple. And then finally, a generated policy is great because it gives the user a place to jump off from, basically, because you can't write one from scratch. You need a generated policy. Oops. So that's what we're going to do right now. We're going to generate a movies policy, and specifically for the person and movie labels. So, oops. I have my endpoint here, generate custom index policy through Postman, and I want to generate it for the node types person and movie. Just to show my graph real quick. I have a graph set up that has, all I've done is just loaded in the movies database. And so you can kind of just real quick see, hey, here's some, movie nodes, The Matrix, Keanu Reeves, etc. So if we click this endpoint to generate it for person and movie, it gives us back, this big JSON. And what we want to do from there is save it. We want to save the index policy. So paste it into the save endpoint and run the save. Great. So now, generated and saved our index policy. What does that get us? Not much currently. What we need to do is actually use that index policy to save things. To index things. And that can either be done through, by clicking endpoints like I was just doing, or you can set up event-driven indexing. Just some notes on indexing. There's a lot of different options. It's really customizable for if you only want to index, if you want to index everything, even things that have already been indexed, or if you only want to index things that aren't yet in the index. It's scalable and it's asynchronous, and that's done through the use of brokers. Brokers are basically just like queues. We set up some queues, put some messages in them. And one of those queues is for failed messages, so that way if a message fails, we know it didn't get indexed, and we can look at what the failure was caused by. Lastly, this is pretty tried and tested on quite a few of our environments. It's been through a lot of different iterations, so it's nice. All right, so let's actually index the data. So we've oh, what did I just do? Oops, there we go. So we've saved our index policy, and now we're going to run this endpoint that actually runs the indexing. So I click this. Takes a second. Okay, so it comes back with a 200 OK. It doesn't give me any response. That means it supposedly worked. And what we can do to check it is we can try to just really quickly look and search for someone's name like Keanu. So if I search Keanu, I'm hoping I get back Keanu Reeves. And it looks like indexing worked. Here's the document. We get back Keanu Reeves, when he was born, his name, etc. So we've actually already met our first design feature. We want to be able to search for people in movies by their properties. We can also do the same thing with, the Matrix. Oh, don't want caps. If I search for the Matrix, I get back the Matrix Reloaded, the Matrix, and the Matrix Revolution, which we wanted to get back, but that also means we haven't met our second feature, because we want to get back the people associated with that movie too. So the way we're going to achieve that is by customizing the index. So we used our generated policy, we saved it, we used it to actually index things. We checked that, hey, we can search for properties, but we're still not done yet because we want more functionality. So customizing index is probably one of the most powerful features in the search module, because we can arbitrarily use any GQL queries to store information about, like, we can use GQL queries to get specific and custom information. So like, right now we're only looking at properties on the node, but if we wanted to go out and say, like, get, the nodes that they're connected to, we can write a GQL query and include that in our index policy to do that. So we have really fine-grained control over the index. I real quick realized I don't have my presenter notes. I guess I'm going without presenter notes. And so this is done through, I guess, like, one thing about customizing an index is to take this concept of an anchor node. And so when we're indexing things, it's used as kind of like from the perspective of a single node, and this picture might help. So if we're indexing Keanu Reeves, then not only can we get the properties on Keanu Reeves, we can go out and write a GQL query to get all the movies he's acted in, right? And so when we go and index him, we'll include all these movies with him. Oh. And so we can do the same thing for, like, another person node, like Carrie Ann Moss. It'll go out and get all the nodes around her. And so we can, like, write a GQL query that works for every single person node, but still gets the specifics for that node. And so that's what we're going to do right now. We're going to implement our second feature by including a list of movies in each person index. So what we would do is we would take our index policy, and I have it set up here. We're going to add these two, oops, shaking. We're going to add these two. So we take our person index in the index policy, and we're going to add these two schema, acted in and directed. And what these are doing is it's looking at the person node we're standing on for when we're indexing, and we're getting all the movies around it. And so if someone has acted in a movie, we'll be able to match it. And if someone has directed a movie, we'll be able to match it and store it in this directed property. So this is we've edited our index policy. Let's make sure that we save it. Yeah. Great, so I've saved it. Now what I have to do is, due to some Elasticsearch specifics, I need to actually delete those indexes. Now we can re-index again, and this time when we get Keanu Reeves, if we search for Keanu, we not only get back Keanu Reeves, but we get back all the movies he's acted in. And if we search for the Wachowski sisters, we get back Lily Wachowski in the movies she's directed, and Lana Wachowski in the movies she's directed. So what we can do now is, if we search for The Matrix, not only will we get back those movies that we were originally getting back, but the search is now going to, because Keanu Reeves' its document contains things like The Matrix and the movies he's worked on, this query will actually hit those too. So Carrie-Anne Moss acted in The Matrix. Keanu Reeves is in The Matrix. So we actually met that second feature by changing our index policy. We didn't change our queries at all. We just changed how data is being stored in the index. And by including what movies people have acted in or directed, we can be able to retrieve their, anytime we search for a movie, we can retrieve them too. All right, so search is pretty cool. There's definitely a balancing act between indexing and search queries. You don't want to put everything at search time, because sometimes if you don't index the right information, you just can't search for it. At the same time, there's a lot of features when you search things that you can't do while indexing, and we'll kind of talk about that later. So what I want to talk about now is continuous indexing, which is event-driven indexing. Basically, it makes sure that anytime we update something in the graph and it should be indexed or searchable, we make sure that our Elasticsearch indexes are updated. So any new data, functionally this means any new or updated data that comes in to the graph, it's immediately searchable. One limit on this is right now it only works for simple schema, so the nodes on the properties essentially. It doesn't work for, I can't write an arbitrary gEquals query and have that just be picked up magically. Not yet at least. We're working on it. So let's set up continuous indexing for the movie graph. So if I keep forgetting I don't have to exit this. So if I search for Keanu, we get back all that stuff that we had just seen. Great. But if I, let's say, update, I find out that Keanu's birthday really isn't in 1964, but instead it was in 2020, and I set that on him, so he's only 1 year old. We've updated our graph, but our Elasticsearch index, when we go and search again, it still says 1964. So there's a disparity between what's on our graph, which is kind of like our source, our knowledge graph, it's our base, and Elasticsearch, which just helps us search things, and that's not good. So that's why we use continuous indexing. So we're going to set up continuous indexing by calling this continuous indexing endpoint. You just hit the endpoint, and now if I say, no, he wasn't actually born in 2020, he was born in 2000. I update it. When I go to search for Keanu again, magically, he's born in 2000. So you can see any updates to the graph now that I make, I can not only change that, but I can change, the name to Keanu Reeves. Now, if I search for Keanu, I'm probably not going to get him. No, I did. It matched on Keanu Reeves. That's because this type of search is already kind of doing some fuzziness, and we'll talk about that later. So that's continuous indexing. Any changes that you make to the graph can now be immediately reflected in Elasticsearch. Great, indexing is done. That's all indexing. The remainder, we're going to talk about searching. Searching, we're finally able to do it now that things have been indexed. So as I mentioned previously, search is a wrapper around Elasticsearch. And so any kind of Elasticsearch query that you'd want to run, you can run it through our search. And often you'll be looking at not only probably, if you're using search, just how to format it for boot search, but you might need to check out some Elasticsearch documentation too, because they have some good usage of how do you use these things. Anyways, the search index still uses our index policy, so indexing isn't totally gone. Because the index policy contains some static information about, hey, filter these things out always, or hey, if someone calls, this, if someone tries to search for this, make sure that the index policy says that their role can actually view it. And so there's two different types of search, the simple query and the advanced query. And then there's search ShowMe's too, which are basically named and parameterized searches that you set up. So that way, later on, something can call them really easily without having to specify the query each and every time. The simple query is a bit of a misnomer, in my opinion. And that's not our name per se, because remember, this is a wrapper around Elasticsearch. The simple query is essentially the whole query is in a string, and it's really concise, and it's great for throwaway queries. So those queries that I was running here, this is a simple query, and yeah, it's simple. It's nice because I can just immediately change it and change what I'm searching for with ease. It supports some basic features of paging, fuzziness, etc. That's why Keanu matched for Keanu matched for this Keanu Reeves, because it's only one character away. Oops. Okay. Now the advanced query it exposes our entire search functionality, and this is what will usually be used by a front end that's calling search. It's a little bit more verbose, and it allows a lot more control. It also has full support for filtering, sorting, paging, all the things that you like. And so, just to show off what an advanced query would look like, it would look like something like this, where if we wanted to say search for movies in the 90s and sort them, we would say, okay, we want our query type to be a range. We want it to be greater than or equal to 1990. We want it to be less than 2000. And then we want to sort them by when they were released. And if you're wondering, this query, for Postman, I have to encode it. So this stuff is just the encoded version of this query. And you can do that directly in Elasticsearch, or in Postman, if I decode it. There's the same query. Oops. But anyways, our results come back. We have 20 movies. The first one we get is a movie from 1990, and we look, and it looks like they're going up by date. So they're sorted, it seems, and the last movie was 1999. So these are all the 90s movies that we have. So this is something that could be like leveraged or even turned into a canned query where instead of specifying a specific date, we could have like a start date and end date parameter. And then that way, if a user entered, in a text box, I want movies from like 1980 to 1990, a front-end API could plug those in and call this endpoint. There we go. And so in summary, search, boot search allows us to search for information on the graph. It does that through indexing it into Elasticsearch, and then results are searchable. Thank you. And next up, we have Harry, who's going to be going over natural language processing and its applications.
All right. Hello, everyone. I'm Harry Dunham. I'm an AI engineer. And as Alex just said, I'm going to go through NLP. I'll do a deep dive. So to that end, we have to start all at the same space in place. So I have to first give some definitions so that we're all on the same page. So what is NLP? Well, you might have heard it from various people before me, Mike and Alex, saying it's an acronym, natural language processing. And so what is that? And so that is a way to programmatically define ways to understand text and spoken words. And the key idea here being that we want to emulate human capabilities of text and voice comprehension. And so, sure, that makes sense, but let's get some tangible examples. So some tasks, because that's what we consider them for NLP, include voice-to-text comprehension. So a lot of you have probably interacted with this in some shape or form, things like Siri, Alexa, anything that takes in your voice as input and does something with it is using a voice-to-text comprehension model. And of course, another one that everyone may have seen or used at some point is translation, something like Google Translate. And then something more nuanced that can sometimes be a component of larger models is something like part-of-speech tagging. So when we think about translation, if I translate a verb from English to Spanish, I really hope that, hey, my verb in Spanish, it's a verb in Spanish, it's not something else, because that probably wouldn't do a very good job of translating. So now that we know what NLP is, I have to get you on board with why you should care about it and why it's included. And so first I want to mention that text data is everywhere, and it's only getting bigger, it's only expanding. So I have a little graphic here on the side, and it's from 2018, and it goes through a bunch of different things that generate text data in some way, shape, or form for every minute of 2018, and it's an average. So you have things, pure text sources, things like social media, Twitter with tweets, Reddit with comments, Tumblr with posts. These things are pure text data. And then you have more, indirect ones, so Amazon shipping packages. There's probably back-end tracking of where the package is, where things like that. So it's everywhere. And if you look at some of these figures, it's kind of crazy how much is happening in 1 minute. And hey, this is still in 2018. So if we think about if it's growing and becoming more present everywhere, then when we're looking at this in 2021, some of these figures might be even larger. So with that said, I think it's important to note that when we have so much data here, we need ways to actually understand it. Sure, if I have 500,000 tweets that were generated in a minute, how do I actually get a sense of what anything actually contains in those tweets? How do I want to get meaningful information out of that so that, hey, maybe I can understand what people are tweeting about? And so that's what NLP can do. We can get greater insights into this data. So whether that be Reddit comments or Amazon, packaging, tracking, things like that. And so with that said, also with how big some of these things are, we also need ways to organize data. So that can include things like, similarity clustering. How can we find things that are similar and group them together so that we can better, parse our data? So now that I've talked about why NLP matters, and hopefully you understand that it's everywhere, we have to talk about where it is in GraphGrid. And so we have 3 primary modules. So we have NLP model training, and that's Python-based. We have NLP, which is Java-based, and then we have Airflow. And that's somewhat indirectly related to NLP, but it's also Python-based. So I'll jump right in. So NLP model training. So as I said before on the previous slide, it's a Python-based module, and it's primarily concerned with training NLP models, hence the name. So the main way that it achieves this is by leveraging TensorFlow. And we use TensorFlow to define custom models, and those are dependent upon the specific task at hand. So, just like, translation is concerned with translating words, that model's architecture has to be tailor-made to the NLP task that it is trying to do, translation. And so, along with dynamic architectures for each different model, we also need tailor-made steps within this NLP model training pipeline for each model, because, hey, my translation model might be trained differently from how my part of speech model is being trained. And so we have a dynamic pipeline to address that for each individual model. And similarly, so we have a lot of different corpora or data sets for each model. And this mostly is for the goal of, models typically are the most performant on data that it is trained on. So, if I train an entity recognition model on a cooking data set and say, hey, give me all the entities that are in cooking text, and then I try to throw it at a political data set, it's probably not going to do very well trying to pull out political figures and things like that when it was trained on cooking stuff. So, we want to have a plethora of data sets and corpora so that, we can get very niche models that are trained on, say, a cooking data set, but we also want generalized ones that can perform in any given text data set. So now that I've talked about NLP model training, I'll talk about the NLP module. So as I mentioned before, a couple slides back now, it's a Java-based service and primarily for graph-based data processing through these models that are trained through NLP model training. And so the key idea, if I were to summarize it in one little point here, is ingesting textual data and extracting relevant information into the graph. And so this is what I was talking about before, of trying to gain better insights into data. And so while you might think, hey, it's just loading in these NLP models from NLP model training, that's not actually entirely true. It actually expands on functionality. And the 2 primary points of examples that we can give is through similarity clustering and summarization. Those aren't things that a specific model handles, but it's a culmination of different outputs from different models to arrive at things like that. And so, I've talked a lot about NLP models, tasks, and things like that. So you might be curious now, what actual models do we use and what are they? So I can go through a list here. So part of speech tagging, as I think most of you know what a part of speech is, so that's pretty self-explanatory. Named entity recognition, so how I would describe that would be, extracting entities. So we have 4 broad categories of what an entity could fall into: a person, a location, an organization, or some miscellaneous named entity. And so that's concerned with taking in text data and trying to get those out. And then co-reference resolution is taking two pieces of text data as input and trying to determine whether they are referring to the same entity. So something like the example I always give is John's sandwich and his lunch. Do those refer to the same thing within the textual, in the text data? That's what that task is attempting to address. Sentiment, so another pretty self-explanatory one, whether text data is positive or negative. Key phrase extraction, that's concerned with taking out key phrases from text data. So things like how you would summarize a piece of text through a key phrase. Relation extraction is kind of similar to named entity recognition and co-reference, but it's actually trying to understand the relationship between two entities. So you can think of things like family relations, like brother, sister, or you can think of relations such as works for, like this organization, and things like that. So it's more concerned with how entities are related. And then yet again, translation, another pretty self-explanatory one. And so now that I've talked kind of at a high level about NLP, I thought it would be helpful to actually go through what do these models actually look like when you're transforming text. So I have a little GIF here. It started a little bit in the middle of the GIF. So I'll let it loop through once, and then I'll break down each individual image within this GIF. So you'll see, starting out with hello world, that's the example text we'll take in, and it'll go through some steps, and I'll explain all of them. So. Okay, so as I said before, hello world, that's where we're gonna be our starting spot with our text input. So the first thing that we do is called word piece tokenization. And what is that concerned with? So you can see that, hey, we arrive at hello world, ! exclamation point. What does this mean? So word piece tokenization is attempting to reduce the needed size of a vocabulary for our models. So all of our models are trained on a specific vocabulary. And rather than needing some massive vocabulary that includes any word ever spoken or written ever, we want to be able to compact that as small as possible. And so that also allows us, to take in, we don't need a training sample for every single word that ever exists, right? So word piece tokenization here, it says, hey, hello world, ! is actually, world ! isn't one word. We don't need that in our vocabulary. We can actually separate that into the word world and then punctuation, ! And so when you think about things like, if you're taking in Reddit comments or tweets and things like that, users aren't going to be using, things spelled correctly, or, there's going to be crazy punctuation and things like that. So we want a way to limit the potential massive vocabulary. And so to that end, then we just convert it. These are the indices of these words within our vocabulary. So hello is the 8,667th word in our vocabulary. Cool. So then we actually get into BERT. BERT is a model released by Google, and you can think of it as a model that has been trained on a massive data set that was tasked with identifying the contextual relationship of words within a given piece of text. And what you can do with it is you can actually improve other NLP tasks, other models' performance using BERT first. So this is what hello world turns into. And so BERT actually will produce more output that exceeds the number of tokens in our word. So it produced up to 128 tokens in the embedding, but hello world is only 3 tokens. So we actually only take the first 2 in this case. And then we replace everything else with 0 because we don't need them. And so for this demonstration, I chose named entity recognition. And this is the prediction from our current models, from our current named entity recognition model. And so, hey, that doesn't really look like much, Harry. What is that? So if we actually convert that to the text representation of that prediction, you see a bunch of O's and then something that says LOC. Well, what is LOC? LOC is a location. So our named entity recognition predicted that world ! Is a location. And hey, That's actually true. That's correct, right? And so you might be thinking, well, yeah, Harry, I could do that myself. The world is a location that's not very challenging. But the point is, hey, you don't have to do that. Our models can do that automatically. So when you think about 500,000 tweets in a minute, do you want to go through all 500,000 tweets and pick out all the locations for me? Probably not. So that is the point of why we should get on board with NLP. So then the last component here is Airflow. What is Airflow? I'll start with a definition. So it's a platform to programmatically author and schedule and monitor workflows. So what are these workflows? You can think of them, they're primarily realized through what are called DAGs, directed acyclic graphs. And you can just think of them as some type of goal that is broken down via tasks, which are executed through operators. And the example, because that might be not entirely helpful to understand what they are, is we've actually converted the NLP model training pipeline into a DAG. And every task within that DAG is a step within that pipeline. So things like retrieving all of the data sets for a model, then training a model, then saving a model and evaluating it. And so that's a primary or a simple example of what a DAG is. And so while I gave NLP model training as an example, DAGs can actually take on any form to tackle any type of task. They're very open-ended, and they're not even language dependent. Other than Airflow being Python-based, it can run any type of language given the proper bundling, but it's not dependent on anything. It can really run whatever. Anything that you can think of that can be broken down into tasks can be employed through Airflow. And so I spoiled it on the last slide, so how is Airflow actually related to NLP? I said it before. And so, yeah, we've transformed the NLP model training pipeline into a DAG. And so what was the main goal of this? Why did we do this? So we needed to establish an architecture to manage training in the cloud. Previously, we had engineers training models locally, and if anyone's ever trained a model here, it saps all of your resources on your laptop or computer, and it doesn't really allow you to do anything else. So establishing the NLP model training pipeline through a DAG with Airflow allows us to manage this training somewhere other than my laptop. And so an inherent benefit of that is reducing any type of I/O collision and being able to train multiple models at once, things that you could never really think about training on a local machine. And so similarly, it allows multiple users to train concurrently or manage the DAG concurrently. So that's pretty cool. And so the last slide here, a look into the future. So where are we going with Airflow? Templatize projects and DAGs to streamline this DAG workflow. I talked about it before. DAGs are very open-ended. We can do them for anything. So if we come up with ways to templatize them to make their employment easier to use, that's something that we're looking into. And of course, I can't talk about NLP without mentioning that there's always going to be new tasks. There's always going to be new models. So that's another thing that you can look forward to. And to that end, I actually want to show off some things. So I do have Airflow running here locally. And this is what I was talking about before, the NLP model training DAG. And so you can see we have tasks here such as retrieve resources, train a model, save a model, evaluate a model. And simply, I would give it a configuration JSON of, hey, I want to train this model. Where do I want to save it? Things like that. So it's pretty self-explanatory and easy. I ran some this morning just so that you could see, and you have logging with what happens during the training session and things like that. So if multiple users are running things at the same time, they can all manage their own training sessions independently. And so the other thing that I wanted to show off, which is something that I think is kind of cool, and it'll take a little second here because I have to start up CDP. So hopefully that doesn't take too long. And I'll open up ONGDB when we get everything squared away. It'll take a second here. Okay, cool. So what did I do? So I took all of the slides that have been presented here or going to be presented, or my own current ones, and I've actually created them as nodes into a graph. So I created the node type slide, and you'll see the text on the node itself is the title of the slide. So you get things like, why GraphGrid, welcome. You get things like that. So that's kind of cool, right? And so the node itself contains the content, the text data within the slide itself. So that's kind of cool. But instead, because I was just talking about it, why don't we only take the slides that are mine? Just so that we can get a better insight, since I was just talking about it, about my own slides, so you guys are the most familiar with that. So here are all my slides. It's only 10 because I only had 10 that had text. I had the picture on a lot of them. So I wanted to walk through what actually gaining new insights into real data would be. So this is a slide data set. I took all the slides, I converted them into nodes. So what kind of things can we get out of that? So if I took the slide airflow in NLP, we can see here it has annotated text. And this is an annotated text node. You can think of these as the output of all of our NLP processing. And so if we expand this, we can look at various information that is associated with the slide I talked about, airflow and NLP. So one of the things is, we have a mention here, is cloud. So I talked about cloud in airflow and NLP. And that's actually included in the summary sentence for, if you can see, there are a couple nodes in the way. This is considered the summary sentence for this slide. And so that one says it establishes an architecture for training in the cloud. Hey, that's actually a pretty good way of summing up what I talked about on that slide. That's pretty cool. And we get a mention here of, hey, I talked about the cloud here. But that's the only instance here where I've talked about the cloud. So what if instead, rather than looking at just a single slide, what if I wanted to look at more insights, potentially? So yet again, I'll do the same thing. I'll take the NLP model training module slide. And we can see, hey, yet again, we have sentences here. And yet again, we have mentions. So Python. Python was something I talked about in that slide. I said it's a Python-based module. Cool. Did I talk about Python anywhere else? And the answer is yes. I did that intentionally. I did that because I had a slide, where is GraphGrid realized? Right here. Where is NLP realized within GraphGrid? And yet again, I had two mentions there of Python. I said Airflow is Python-based, and NLP model training is Python-based. So hey, I have a connection here between these two slides that I talked about. That's pretty cool. I can get an insight based off of that. Well, okay, I'm still in the realm of just talking about my own slides. What about other slides that people have presented? Where is my connection there? So if I actually expand this annotated text node to get everything, we actually land at a similarity cluster for a bunch of nodes now. Now it's kind of a crazy web. And this is the similarity cluster node that groups all of these. And you might be saying, okay, why do all of these nodes now, why are we related? And that's because I said one of the key reasons why is because I mentioned GraphGrid in that slide. It's in the title. I said, how is NLP realized within GraphGrid? And so GraphGrid's pulled out as a mention, and it's clustered into all other slides that are similar to that. So it's kind of cool. So I haven't looked through any of these, so I can take this random annotated text node here and look and see, hey, I get a slide, GraphGrid CDP version 1.4 edition. So this is made by Mike. Maybe I don't know if he's talked about it yet, so I won't go into the specifics of what's behind it. But so this is, there are a ton of nodes here. And I could actually walk through how's my slides? How are my slides related to any of the other slides in this presentation? What is the relevant information behind this? And you can even take things out of this. You can continue following this web of, okay, I have a mention here. Where else are things like this mentioned? If I find an ONGDB node for a mention, I can look at where ONGDB is mentioned throughout all the other slides in case I'm interested in more information like that. So I wanted to give a little demonstration here just to show off, talking about NLP, sure, it's great. But I think I really wanted to drive home the fact that, hey, I can actually get really cool insights into how all of these slides that maybe are unseemingly related, how I can actually visually see how they're related and the information that actually connects all of them. So that's all I have to share today. I hope that showed everything in terms of why NLP matters. And this is just the tip of the iceberg in terms of what information you can get out of this. So thank you.
those that have been following the whole morning of agenda here, I have the unenviable task of following Alex and Harry and their presentations on search and NLP. So if your brains are still relatively intact from those presentations, we'll step into what's going to happen in CDP 2.0. My clicker. It's all right. All right. So at the high level here, kind of areas to focus on or things we're going to introduce or level up in 2.0. We have a config cleanup and a new API version. We're going to continue on the dev role focus that we're very focused on and is important to us. We have kind of some new considerations for search with continuous indexing, leveraging Fuse. We have some new UI capabilities, and then lastly, there will be a new edition introduced called the AI edition. So we're going to spend a few minutes talking about each of these to kind of give you a feel for what the motives are, what the ideas are behind them. Starting with configuration and API 2.0, the current 1.4 CDP is built on the version 1 of the API, of course. So that's served us well. It's kind of the culmination or what's come together as developments happened for the full cycle of all the 1x version, iterations of the CDP. But as you would expect, over time, things kind of get a little bit unwieldy or just not as organized or clean as we'd like. So it could use some attention. And so we'll be, kind of revisiting the API to better organize, introduce, more uniformity, more standardization, get things there, just more usable, more user-friendly, more self-evident and apparent how to interact with the API, and it's just cleanup. I mean, it's technical debt, the kind of thing that you don't like to spend a lot of time on, but it's also very important and relevant that we get off on the right footing and don't let that go neglected or by the wayside for too long. So it's going to be a focus for 2.0 to introduce a new API version, which is really the reason why CDP then goes to a version 2 for the platform. Similarly with config, as you get into adding more parameters and config grows, it can kind of be less organized than you'd like, less uniform than you'd like. So we're going to be looking at that to really get us into a better place to build on and move forward from 2.0 into the future. And all of this kind of qualifies or kind of lives under the quality of life that we want to offer and present to our users, to our developers, to our operators, so that it's easy to understand where to find things, what you need to call, how to organize within config and API. So it's important from that perspective. I guess, kind of in general, the focus on trying to serve developers and trying to have things be as obvious or straightforward and usable is the motive here. DevRel focus, I touched on it in the 1.4 conversation. This is something that we take very seriously, something we put a lot of time and energy into, and that's only going to increase as we get ourselves out there and start getting users generating feedback, to have a presence on certain platforms. We've prioritized Reddit and Discord at this point. We'll also be doing some video content for tutorials and other material to be on YouTube. So look for that in the really not too distant future. I think we'll have our first stuff out on YouTube in a matter of days, if not tomorrow. We'll see how that goes. But certainly, we're going to continue to focus on content to support our user base, our customers, meet their needs, help explain what we're doing new, what we're changing in the platform, so that there aren't any surprises or anything that trips people up. That's just again, kind of a fundamental priority to us, and it's something we take very seriously, and it's very important to us. Moving on to some, actual changes in the platform. Search is something that Alex went through in pretty significant detail as far as how we leverage Elastic for indexing and how everything's working there. What we've realized is that through the iterations that the current architecture that we've done in the current architecture, that there's limitations, or we're kind of going to reach a point where it's not going to scale or be as performant as we want. So it's kind of an architectural change or look to introduce Fuse and take advantage of the event-driven capabilities within Fuse, that module in the platform. And so that's a big piece of that. It's also setting us up to do more with search in the future, to give you more control over how you can use search to look at the different subgraphs and get into the data better and have just more hands-on management of search through how it uses Fuse and how the data is changing and how we can reflect that change in real time, be more performant, more reliable, et cetera. And then, on the reindexing piece, that's a key thing as well, is to offer more control or, refined abilities to respond to changes in the data and when and how you reindex. Touched on this in the 1.4 also, so if you missed that earlier, you can go back and watch that portion of this agenda this morning. Our UI is at a point where we need to continue to build out to support more of the API through the front end. And probably the most significant piece of that since I've been on board and involved here is the manager capabilities that we offer to control your manager model, define and organize your knowledge graph. And so right now that has been mostly relegated or available through the API directly. To add a front end to it has been a pretty significant goal that the team here has had, and we're very close to completing that, and that's going to be introduced in version 2 of CDP. Super excited about that. Some of the people in the room here with me have put a lot of time and effort into that, and it's coming together. So that's going to be a big piece to better control your manager model, better to control kind of how things are organized and set up for your knowledge graph. Similarly, ShowMe UI is something that exists, but it just needs kind of a level up, kind of some attention to make it more fully featured and kind of have or better connection and awareness of the manager, of the graph in general, and just some overall usability improvements. So we're going to be looking seriously at, we have to kind of finalize the scope. There's a lot we could do with ShowMe from a front-end perspective. So we're still in the final stages of deciding just exactly what that looks like in 2.0, and then there'll be certain things that we'll certainly be building on to even improve ShowMe's beyond in future releases. And then lastly, there's just kind of a UX mindset that we want to start looking to leverage more. The front-end experience is probably more geared towards analysts, data scientists, not as dev-centric, which is kind of where we are with CDP 1.4. But as we look to release 2.0, we're going to look to improve the user experience, make things more intuitive, easier to navigate, easier to understand through the front end as we enable more of the API capabilities through the front end to be sure that we have that UX mindset. I'm moving right along here. So lastly, and this is something that is a big deal, and as if you were available or listened through Harry's conversation about NLP, what you have to realize is with the Enterprise Edition for 1.4, there's some limitations in what that offers, in that we're just kind of packaging the models for NLP, and that's what you get with that edition. What we're hoping and expecting and planning to do with the AI edition is to bundle Airflow, bundle some machine learning capabilities, and allow you to train your own models on whatever data set you have. So that is like blowing things wide open, and it's really exciting. It's kind of a leap forward. It's not just a little jump or a little step forward, so it's significant. And it's something we've been building towards and had our eye on for a while, and to be able to do it and plan to pull that off here in the next, hopefully, 8 weeks or so by the end of the year, we're excited. I think the the opportunities that opens, the capabilities that presents to extend to whatever data you bring to the knowledge graph and be able to train new models on that data, and then everything else on top of it. That's just such a massive leap for us in what that AI edition will offer. So I'm excited to use it. I'm excited to see it in action myself. There's a lot of work to do still to get us there, but we're definitely on our way. And this is going to be a great opportunity to really leverage the GPU aspect of our freemium. So kind of a plug there is, the AI edition will also be available as a freemium edition. And what that can do to train your own models leveraging GPU performance is a big deal too. As I said, we're going to bundle Airflow in that edition, as well as ML capabilities. More to come as far as documentation and supporting materials as to what that looks like in specifics and how to use that. So we have, that'll accompany, as it always should, so that you understand how to leverage and how to make use of these new capabilities we're going to add. And I guess, the third bullet here is around similarity clustering. We've realized, and we've had a couple patch releases, even since 1.4 went out 5 weeks ago, that there's some improvements in our similarity clustering. And so the algorithm or algorithms there are getting kind of a look to make them more performant and basically do what they do. And I can't speak to it because I'm not the big math engineering brains that we have in the room here with me. But they're doing a lot of cool stuff to make those work better, be more performant, and really kind of grow with or adapt to whatever the knowledge graph has in it on that side. So I guess I rushed through this pretty quickly here. There's a lot of cool stuff that we're looking to do in 2.0 and beyond. This is kind of the highlights for what version 2 of CDP is going to include. The big headline is the AI edition to allow you to train your own models, to include Airflow with that and some ML capabilities. Certainly we want to be more granular in explaining what exactly that looks like as we come to a full definition of how we're going to have that implemented in that version. So look for that with the docs and tutorials releases that will hopefully coincide with that. But 2.0 is targeted for December. More specific date as we get that nailed down as well. But yeah, I'm excited about the future of where GraphGrid's going with CDP2. I think it's a big deal to kind of prove that we're not just launching 1.4 and that's kind of where we're going to rest for a little bit. We're in motion and looking to what's next for 2.0 here, as we've discussed, and what's beyond is a lot of the same or even better to come. So I'm going to turn it over to Ben here shortly for kind of a closing keynote. But thanks.
All right. Hey, everyone. I'm Ben Nussbaum. I'm the CTO here at GraphGrid. And today, as we close out the very first conference, we are going to talk about what we've been doing in the lab, some core principles and promises that guide us, and what we can use now, and when you'll get your hands on the latest capabilities that are in our upcoming releases. But before we look to the future, sometimes it's very helpful to look to the past, because before we can transform the way we live, work, and play tomorrow, we need to take a look back to understand how we got here and where we are today, and then we can project our path forward. When I started creating software in the mid-90s, the internet was a symbol of freedom and possibility. If you could write code, you could reach the world. Unlike any industry we've ever seen, it is completely accessible to those that want it. I, as a 12-year-old kid with no special schooling, living in the country in Ohio, with nothing more than an internet connection that's much slower than everything you all have on your phones today, I could find the resources, documentation online to teach myself what I needed to know to wield this power of code. Largely where this started was a local furniture company had a website that had been made using static HTML. This was my first job, was to take over and kind of improve the website. And when I started looking at it, there were 175 individual HTML pages. And the first thing they needed done was to change the phone number. And that required editing 175 HTML pages to change the phone number. And this immediately prompted in me, there has to be a better way. And so I started looking and realized that PHP at the time was a thing. I think it was PHP 2. And figured out that I could make a little snippet that I could then insert into the header and render the whole page with that header once and edit it once without having to make the same change 175 times. And that has been a core learning that has always driven and pushed us as I've gone in my career and as we've gone and as we are going at GraphGrid. There has to be a better way. And so this driver is consistent. We're always looking for that better way to live, work, and play. And it continues to be, us developers that are tremendously influential and and with GraphGrid, we want to empower developers in the age of AI to more readily create the future that we all will live, work, and play in. First of all, let's talk about embracing the power of developers and their code. So in the last decade, there has been a trending focus away from developers' ultimate source of power, with low code and no code being pushed forward as the future of how you work with increasingly complex data, analytics, and AI processes. So much so that Gartner's major conference last year, by my assessment, included in their agenda over 70% of the tracks in some way dealt with this concept of the composable enterprise, which is notionally that non-technical business users will be able to piece together comprehensive enterprise systems from infrastructure and data tiers through UI components without requiring a developer to write code. On the surface, this sounds like wonderful culmination of decades of developers wielding the power of their code to surface to non-technical users interfaces that allow them to perform increasingly complex tasks. However, as we started dissecting this utopian vision of the composable enterprise pieced together through UIs only, there were several major pitfalls that will likely prevent organizations from being successful. The major ones were code persisted to a database via UIs, complex data workflows managed via UIs, lack of change management, no CI/CD and security controls in promotion going to production. Because when you have code in UIs, and you're clicking buttons to make changes, you don't have a way to replicate exactly what was there on another environment. You're relying on a human to click buttons and be consistent. So for example, you could make 1,000 clicks to set up all your networking in AWS, your VPCs, your subnets, everything that's infrastructure related. And in order to move that and apply it to another environment and replicate it exactly as it was, you would need to redo those thousands of clicks to set it up in the other environment. And so infrastructure management has evolved to the place where we use things like Terraform. Infrastructure as code, can easily deploy it out, and it gives you the exact same state every time. If we've learned the importance of this for managing infrastructure, why do we think about data and analytics and AI processes differently. With GraphGrid CDP, you get to treat your data and analytics and AI models the same way, using code in all the right places. Not everywhere, but the right places. And it's really important that we, as a product team and as the CTO's office and everything at GraphGrid, when we look to the future of it, we're looking at what are the right places to use code and to let developers wield that power so that you can reliably replicate these data, analytics, and AI model processes to other environments. For organizations to succeed with AI systemically, developers must remain the hero of the story. We have to let them use code in all the right places. And now as organizations navigate towards and through the rise of AI, the developer has an even more important role to play in this epic tale. And GraphGrid CDP is developer first. With it, developers wield more power from their code than ever before as they lead organizations in the continuous curation of a strategic knowledge asset that drives organization-wide augmentation with AI. We want to be able to have complex knowledge processes that organizations can offload to AI and let humans do what humans are really good at and let the machines do what the machines are really good at. And to do that well and not get stuck with UIs needing to be clicked and managed for everything and to move at the pace of AI, we need to use code in all the right places. And that's what we are focused on, one of the things we are focused on at GraphGrid. The next thing is tooling to create a collaborative environments for humans and machines. As AI continues to rise, in the history of AI, we've seen up and downs where there's usually a lot of optimism about it, and then there's a winter of kind of really low. And AI has been around since, the idea of AI has been around since the 50s. AI to me is widely misunderstood. It's often used and seen as this magical thing that you can just kind of sprinkle on any organization's system. Everybody needs AI today. And it'll do amazing things if you just apply AI to it. And really, AI as it is being implemented today is far from that Terminator-esque cognitive capability that rivals that of humans, of the original thought produced by the human brain. It is, though, very good at things that it can be learned and trained to do. Like Harry talked about natural language processing, there's a lot of training, right? There's always that training. But to really understand the rise of AI and where it is today and how we can use it effectively, we need to look back to when it was originally defined. And that was when it was back in the 50s. And it's really, a computer can do as well or better that what a human can do. So as long as it can do equally or better than a human at some task, it can be categorized as AI. And I think this is a large contributor to the variance and resulting confusion in the marketplace where there are so many systems being described as AI, and many of them leave stakeholders that aren't technical wondering, how is this AI? Because everyone hears AI and they think that Terminator fully cognitive, like, oh, it can think and actually do things. But that's really not the case. So regardless of the variance in systems being categorized as AIs, we and our customers agree that we want AI systems to be trusted, with reliably solving useful problems that are difficult, tedious, or time-consuming for humans to do, be able to be conceptually understood, bounded, and measured and refined by stakeholders at all levels. It shouldn't be only an AI engineer that can understand conceptually what the model is going to do and what the output is, input it needs, output it produces in order to be successful in the value that it adds to the business, and remain aware of the current organizational operating environment. So we want our AIs to have context, understand context, and learn from that. The good news is that all of these are more achievable than you may think. AIs today are quite simple systems when you set aside the complex mathematics of the underlying implementations and look at the mechanics of how they work procedurally today. So we're going to do that here real quick. I find it helpful to think about AI like children. If you've ever watched a child learn the alphabet, or if you've learned a different language, you'll be able to relate to this. The child has a letter presented to them in association with something they understand. So A, apple, B, ball, C, cat, right, etc. The child repeatedly goes through these letters and associations and slight variations from only the letter to the letter emphasized in a word with a picture of that thing. The child is tested on their understanding by showing them a set of flashcards in a similar font and format to the ones they've learned from, and their percent accuracy is measured. The child is at a grocery store in front of apples, and their parent points to the A, asking them, "What letter is this?" And the child doesn't know. The parent then provides the feedback to the child that is the letter A. The child updates their understanding to include the possibility that a letter can appear in a different font style and a different format. I've seen this with my kids. It's if you are learning on a certain style and suddenly that letter's a little squiggly, or if I write the letter, my handwriting's not great, kids are like thrown off by it. They're like, "I'm not sure what this letter is. It looks foreign. It's still an A." But later, now as the child learns that and sees more variations of A, they go to a different store, that letter A appears again on a large sign. Child tells their parent, "This is the letter A." AIs, not really that much different. They train on some data in either a supervised, where they're receiving input, or an unsupervised manner. They are measured on their accuracy when receiving inputs similar to the training data. They are sent into the wild and asked to answer a question that is similar but not exactly identical to the data that they were trained on. They are trained again with additional data using the examples of what they encountered in the wild, and they improve their ability to answer correctly based on that additional training data. So we end up with, these two kind of parallel procedures for how AIs work today. And that helps us understand how we can use and leverage AI in a system effectively, and how it fits into GraphGrid CDP and what we are providing as a knowledge graph-driven AI system. So all the mathematics used to represent these training models in a relative manner to each other, with its confidence, varying levels and inputs linked together, is done to facilitate the process of learning and answering. Kind of boils down to that. Not everyone needs to understand the mathematics in order to introduce the usage of AI successfully into their organization. An organization can adopt AI without everyone knowing all those mathematics. But understanding procedurally how AIs function is one of the key things that has guided our approach to systematically introducing AI augmentation as a native component of GraphGrid CDP. Because augmentation with AI is a core thing that we see as necessary to be able to drive into the future in order for organizations to succeed with AI. So while AIs are simple in their function, the complexity, however, is introduced by that iceberg of tooling, processes, data security, governance, needed for them to make sure they are on the same page as us humans when providing outputs expected of them. Because if we don't keep them on the same page as us, we're just going to be missing each other, and we're not going to be getting the value that we need from our AIs. So without this iceberg available, organizations end up in this cycle where they have a really great AI engineer, somebody that can build an AI model, and they build a one-off model. It gets used, it gets put into production, but it exists outside of a repeatable, measurable, and improvable process. One of the reasons that I have experienced myself when I'm developing is that it is really hard to be creative with data and process-oriented thinking at the same time. So if I'm trying to be creative with data, which is kind of tied to building an AI model, training an AI model, you're usually dealing with the data that you have, how can you make it work, what are the right attributes, all of these characteristics. It can be really challenging to then switch to, okay, how do I take this, put it into a process that's standardized, repeatable, measurable, secure, all of these things. So it's two very different schools of thought. And so one similar challenge I've seen limiting the introduction of this iceberg is that to excel as an AI and ML developer, you need to be creative in your thinking in this approach. And you need to kind of free yourself to look at the data and say, what if we tried this? What if we try that? And it's often not the developer that excels at organization and system and processes. Or if they are the same developer, it's really hard to do both at the same time. They just don't really work together. And so the creativity that makes the AI ML developer, model developer great at building AI models can often lead to frustration in their system thinking developer peers, managers, and business stakeholders, because most of what is being done to achieve results is often described in these terms bordering on the mystical and magical. Now, it's kind of that fairy dust, right? You're like, hey, we did some stuff with the AI and the data, and we got this result, and it's answering, and it's awesome. And you're like, okay, well, how do we repeat this? Well, I don't know. We're going to go through the data again and do this. So getting to systems and processes and distilling the AI creation and that training and being able to do it again and measure the output and determine what goes into production and have a system and a structure and a process for doing that is really difficult for organizations to put in place today. And that's part of what we provide with GraphGrid CDP. It takes a team effort. You need both types of engineers, both types of developers, and you need the right tooling and process, because there has to be a structure where you can take your data, your AI models, pair them with the rest of that infrastructure, that tooling, the process for deployment, making it repeatable and measurable so that it can go out. And so how does GraphGrid CDP help? Well, GraphGrid CDP has been architected from the ground up to provide developers with a comprehensive set of tools, technologies, and shared service APIs built for continuously evolving strategic knowledge graph assets that are in turn used by GraphGrid CDP, shared services used for AI model training, and able to be integrated with by developers for usage in custom developed services. One of the really awesome things with GraphGrid CDP is you're not limited to the shared services that we deploy into GraphGrid, the connected data platform. With CDP, you can develop your own microservices to augment and enhance what's available and push that out as well. And we are advancing this powerful set of product capabilities that make it easier than ever for developers to systematically augment all their knowledge work with AIs in a repeatable, measurable, improvable process. One major feature coming in the next release that I'm very excited about to see it's making its way out of our lab, and Harry already touched on this a little bit earlier, but it's the introduction of the continuous training pipeline that will provide all of you AI ML model developers out there with system-wide integration necessarily to rapidly experiment with multiple AI model versions in parallel through a repeatable, measurable, and improvable process where you can test and only advance to production those that perform the best. And so when, like Harry was saying, when you can move it off your laptop, it changes the game. You can have that creative mindset and stay in that creative flow where you say, oh, what if I tried this way of transforming the data and feeding it into my model? Let me do that, commit it, push it, start it, let it run, train. Now I'm on to the next thing. I can start thinking about that. And so it really changes how you develop and how you work in that way. And then once in production, these models will remain current with your organization's current view of the world, thanks to the full training integration with our reactive data architecture. Because once you get a model in production, it can't just sit there, because your organization's not staying static. It's changing, it's transforming. Your data's updating. And so now you need to retrain or update the training for that model, keep it current. And that's kind of that continuous training. And so what does it look like to create a knowledge graph-driven AI system? GraphGrid CDP accomplishes this creation of a knowledge graph-driven AI system through what we've been thinking about and describing as knowledge graph-driven AIs. So yes, we have unstructured data that we use to train AIs, but we also have a knowledge graph, that strategic knowledge asset that our customers curate each within their environment of their data, and it's their view of the world. It is that source of truth. And so when you create that knowledge graph-driven AI system, the goals are really about use the knowledge graph as the contextualized data asset that both humans and machines use as their source of truth. So we want humans and machines to agree. And to do that, we speak a common language. It's a knowledge graph. It's that representation of the semantic understanding of the people, places, and things that are important. And then we augment every process with that AI. That is difficult, tedious, or time-consuming for humans to do. So there's certain processes like reading news articles to identify what's relevant. This is where you start to change and transform the way organizations work. If you have human analysts reading a news article to find things that are relevant to them, that's something that's tedious, time-consuming, very slow. Humans aren't essentially good at that. Something we can push to natural language processing with a machine, push to humans, start changing the way that it works. And then within any system, and in GraphGrid CDP specifically, we are building and focusing on introducing and maintaining a system-wide awareness and usage of your continuously evolving strategic knowledge asset. So that asset that you create needs to be used and understood by the system. It's not just enough for you to create and manage knowledge. The whole system needs to understand and react to what's in it. And proactively, and lastly with that, as data changes in the knowledge asset, we proactively push to humans and machines based on the knowledge graph. There we go. And so with that, there's a couple of ways that GraphGrid helps. We give the developers the tools to create and manage a knowledge graph as a collaboration point for humans and machines. And we give developers a continuous training pipeline that is driven from the knowledge graph. And the way that I think about that and the way that I visualize that, and we make it repeatable, measurable, and improvable, is you really have these context iterations. So across the top here in this graphic, you've got the images of the graph. And essentially it's, you take certain parts of it, you train on it, and then it goes down from the graph, gets turned into a vector so your AIs can know how to use it and understand it because they operate in more of that 2D space than a complex graph with all the nodes and labels. And then you train, model goes out, it gets tested, analyze the results, improve it, and it comes back. And so that AI ML model developer can iterate, add new context, look at new attributes, add new data, and repeat. And as each model comes out of that pipeline, you start to test, verify, and validate, and score them. And then it's not just enough to score them as part of the training data, because as we learned with the children, they're often scored based on something that's similar to what they were trained on. And so you really have to measure that end real-world performance in order to understand how they're performing in production and keeping that real end result for how they're doing. And as we introduce this increasingly complex system, and as GraphGrid CDP helps you accelerate your adoption of such a system, it starts to help your organization by moving the human out of the loop. Part of how we do this is a cornerstone component of GraphGrid CDP 1.4, which is the reactive data framework in the Fuse module. And this basically has a native integration with the knowledge graph, which is backed by open source knowledge graph called ONGDB. It's a native graph database that uses a labeled property graph implementation. So it gives us a lot of great characteristics and high performance as data flows in and as it changes. And it allows us to monitor that data from both a data perspective and graph model, but also a semantic perspective. We want to look at what is the data coming through that, how are things changing, and push that out to services through that event architecture downstream. And we have the foundational pieces of that in place today, and we have a lot of improvements planned to add to the semantic components and be able to improve how it's processing the data changes, how they're being distributed. Largely in organizations today, remain in the loop. And when a human is in the loop, of that process, the organizations move at a slower pace because every decision that it needs made has to go through a human. So kind of that notion of in the loop versus on the loop, and why it's important to move humans onto the loop, and why GraphGrid CDP is being developed to do that, is there are many processes, many decisions that can be offloaded entirely to a machine. When we reach certain reliabilities, certain scores, machines, and we're building trusted AIs that provide reliable output, which GraphGrid CDP is being set up to help you do, we're able to move more of our processes and more of our humans onto the loop, where only certain scenarios that don't provide that high confidence are pushed to them. And so one of the main benefits of this reactive data framework that we have is it can provide intelligence that gets pushed out to your humans. It changes the way you work. If we go look at that idea of 100 analysts spending multiple hours a day reading news articles, social media, looking for things that are relevant. Well, if I'm an analyst or a human or a system downstream that wants to know about things related to a certain topic or a certain region, I can have a machine read the news, read the social media, and push to me. So I only get what is ready for me to synthesize into some action or into some intelligence. I don't have to do that long, tedious, slow process of reading the news. I can take what's there and then act on it when it gets pushed to me as something that's relevant for me to look at. And so this starts to transform the way you work, because you take those 4 hours a day where you were just processing news, social media, looking for things that are relevant for you to act on, and instead of doing that discovery, you let a machine do that, and you then can work based off that thing that's relevant to you and start to take action, synthesize intelligence, make decisions, do everything that's downstream from that. And now the way that you've worked has been transformed. And so GraphGrid CDP is helping organizations do that. And we want to continue to enhance those capabilities with the AI module and the other training components as we help take steps intentional in our design to move the human out of the loop and onto the loop. So from our perspective and what we've done and what we've been kind of dogfooding and pushing towards here, every organization is ready today for useful AI. I just call it useful because, I think this experience of pushing ourselves to help organizations achieve system-wide AI augmentation and make it readily accessible for their developers, it drives the principles and guarantees governing the advancement of GraphGrid CDP. So if you have developers, if you have data, you're ready to implement AI. I was talking to Gartner, and one of their analysts was saying that only about 5% of organizations think they're ready for AI. And I think, and especially knowledge graph-driven AI, knowledge graphs are a little bit ahead in adoption, but it's really surprising because, and I think it's largely the limitation of this iceberg and kind of the intimidation of it. And so what we want to do with GraphGrid CDP is lower the barrier to entry, give organizations the confidence that they can take our freemium, take what we've developed, try it, and see how quickly they can get to applying AI and augmenting AI in their organizations and really taking advantage of that. And so with our 2.0 release, as we've been building up and got 1.4 out for everyone, in 2.0, we're really going to take it to the next level. That AI module with ML and AI and the Airflow training is full of amazing things for you, all you developers out there, because it's going to change the way you build your AI models, the way you curate your knowledge asset. And with every release of GraphGrid, we're going to further empower developers to wield the power of that AI in a systemic way based around a common knowledge graph asset that unifies both humans and machines. And every organization already has developers. They already have data. And so when you pick up and use GraphGrid CDP, you'll be ready to take advantage of useful AI. And so in order to make AI useful for all organizations, our goals with GraphGrid and what we need to make sure that we're enabling developers to do, we're enabling teams to do, and with their AI models that they're able to create, is provide trusted outputs, solve problems that are non-academic, impactful, difficult, tedious, or time-consuming for humans. Those are the ones you want to focus on in your AI effort. And that's what we're focused on in our mind because AI is not academic for us. It's something that we need to be able to make work for real knowledge graph workers that have real problems to solve and real mission use cases, real business use cases. And after you get your AI developed, it has to stay current. You've got to keep pushing it out. And so these are the standards and it has to have awareness of real world context. And these are the standards that we're holding ourselves to here at GraphGrid and what we're pushing for and how we're thinking about the future and what we want to make available for you all. And so with that, in closing here, I'm going to talk about a few guiding principles and a few data guarantees that the platform makes. So first one, don't master data through AI or through any UI that should be reviewable, versioned, and promoted through environments. If you're pasting data into a UI, it's really difficult to then take that and version it and promote it and get another environment into that exact same position. So much of what you'll see coming in GraphGrid is a framework and a way for developers to use code in lightweight code languages like Python, JavaScript, things like that, to be able to set up different data transformations, configurations, get data ready for their AI models. We'll be able to make it easier, lower the barrier of entry, so you're providing simple scripts that plug in, can be versioned, can be promoted, having the entire GraphGrid platform as code and that representation of it so that you can go from GraphGrid on your local machine to GraphGrid in a cloud environment to GraphGrid scaled globally and have that sit there and be integrated with your capabilities, your microservices, and be able to see that it's repeatable, measurable, and you can push it out quickly and effectively and have the same results in all those environments. Next, get the human out of the decision-making loop and onto the decision-making loop. As we look at how we create tooling and systems to augment our processes, enable you to do more with knowledge graphs and AI, we're focused on how do we make AI effective enough that you can augment processes that remove the human from the decision-making loop for the scenarios where there's enough confidence, and really focus on those transformative efforts for how you improve the way you live, work, and play, letting the machines do what they're good at. And then lastly, we need to keep, as we develop this platform of microservices, you saw all the modules earlier in the CDP 1.4 talk that Mike gave. All these modules need to be unified, and they need some connecting point where they understand what is the view of the world that we have, what are the people, places, and things that are important, how do we operate technically, and then how do we keep humans and machines operating with that same view. And so as we build things like Manager, where you can manage that domain, and then search and ShowMe's that are based off Manager, understand it, learn how to recognize it, and know what a person is or what an organization is, these different types that you create, they'll be able to use those capabilities in that shared knowledge context. And that then is the same thing that your AI models can be trained on, so that your AI models become context aware. And when we do this, this advances both humans and machines together. And this creates that system-wide systemic intelligence that becomes the brain of your organization. So as we push into this age of AI, organizations that have a connected context that humans and machines are collaborating around, using machines for what they're great at, using humans for what they're great at, those are the organizations that'll win. They'll advance and they'll excel. And that's how we see the world here at GraphGrid, and that's what we are pushing towards with every release that we build. With that, it's important that we give you a few guarantees. So our guarantees to our customers, to our users, those of you trying freemium currently or that will try freemium after this, your data and AIs belong to you. We provide the tooling, the platform, and that bottom half of the iceberg, but as you saw, that top half, your data, your AI models, derivatives of it, all of that is yours. You put it in, it stays in open source data formats. The models are in traditional standard formats, such as TensorFlow structures, and you are always free to take your AI models and data and go if you want. There's no lock-in, there's no requirement that you continue to use us. We hope you do. We obviously want to provide a great product for our customers so that they have a reason to continue to use us, and that we can help them on their journey by providing tools so that their developers, analysts, teams within their organization can really be the hero of that story as we walk through this rise of AI together. So lastly, we want to hear from you. For everyone out there on the live stream, I hope it's been an exciting insight and look into what we're doing here at GraphGrid, where we're going. Please download GraphGrid CDP, use Freemium to develop, and go to production with that generous offering there. We hope it serves you really well. We want feedback. We want to engage. And then let us know what we should do more of or what we should do less of. And for all of you out there, thank you for joining. Make sure to smash that like button. Don't forget to hit subscribe. We have a lot of awesome tutorials coming from Vanna and others, a lot of solutioning content we're going to continue to push out to our lives, to our YouTube channel, and make sure that we stay connected with you because we want you all to learn and grow and thrive in this age of AI. So thank you.